system of equations with three variables, the first thing you want to do is look at the coefficients of each variable. So here we've got a 1, 2, 4, a -1, a -1, a +2, a 1, a 5, and a -1. And determine which of these variables you want to eliminate. I'm going to go ahead and eliminate y's because 1, 1, or -1, -1, and 2 is smaller than the others. So what I'm going to do is I'm going to call this equation 1. This one's equation 2 and equation 3. And what you're going to do is going to add two of the equations together in order to eliminate one of the variables. So what I can do is I can see that if I add these two equations together, the y's would not eliminate unless I multiplied one of these equations by a -1. I'm going to go ahead and multiply equation 1 by a -1. And then I'm going to add that to equation 2. Okay, so if I multiply each of these here by a -1, it's going to change this to a -1 plus y minus z equals a +3. Sorry, -1x plus y minus z equals a +3. And we can do that because if you multiply one side of the equation by a -1 and you multiply the other side by a -1, it keeps it equal. Okay? And then we're going to just add that to equation 2. Now we can add them together. And I always add, okay, because you make less mistakes when you add than when you subtract. So let's see, this gives me 1x. My y's cancel out, that's what I wanted, plus 4z equals 3 plus 4 is 7. Okay, now we need to do the same process again, but we need to do it for two other equations. So I'm going to go ahead and look at equation 2 and 3 because they're already opposite of each other, so all I have to do is multiply equation 2 by 2. So that'll make my y a -2y, and this one's already a +2y, then they will be able to eliminate. So we'll say 2 times equation 2. Oops, I did EQ this time, sorry about that. And plus equation 3, just like it is. Oops, did it again. Okay, so we're going to multiply each of these values by 2. Because remember, this side by 2, we have to distribute it to each term. So that's going to be 4x minus 2y plus 10z equals 8. And then we're going to write down the next equation just like it looks. Equation 3. We add those two together. 4x plus 4x is 8x. The y's cancel, plus 9z equals 10. Okay, so now we have two equations with two variables left. Okay, so now at this point we are going to need to eliminate one more variable. So we're going to repeat this kind of process one more time, but we need to either eliminate x's and z's. Now it looks like this coefficient of 1 in front of the x is going to make this easier to deal with. So I can see that if I multiply this equation here by -8, okay, and then I can I can add it to this equation down here. This will make this a negative 8x, and it will cancel out the x's when I add it to this equation. Okay, so I'm just going to, since we don't have a whole lot of room here, we're going to times this by negative 8. Okay, I'm going to put this right under here. So negative 8x, and negative 8 times 4 is a negative 32. Z equals 7 times negative 8, negative 56. We add those together, and you get a positive 9 minus 32z is going to give us a negative 23z. And 10 plus a negative 56 is going to give us a negative 46. And we can see that if we now solve this equation for z, we divide both sides by negative 23, and we're going to get z equals 2. Okay, now this is the longest part of this problem. Everything after this is just simply substitution. So we can substitute it back into one of our middle equations here that only has 2 variables, so either one of these. And I'm going to plug it into the top one because it's a little smaller. So we're going to now come up here to this point, and we're going to substitute in, okay, in place of z, we're going to put 2. And then we're going to need to solve that for x. So x plus 4 times 2 equals 7. So this is going to give us x plus 8 equals 7. And we subtract 8 from both sides, and 7 minus or plus a negative 8 is a negative 1. Okay, now we go to the very last step. We've solved for 2 variables. Now we can plug it into one of the original equations and solve it for y, the third variable. In this case, it's y. Okay, so we're going to start with, I'm going to use equation 1. To do that because it's got smaller variables, coefficients. Okay, so I'm going to replace x with negative 1 minus y plus z. Z is 2. And now I have an equation with 1 variable in it. So a negative 1 plus 2, go ahead and simplify this side over here, and that's going to give me negative y, or opposite of y, plus 1 equals negative 3. Now I'm going to go ahead and subtract a negative 1 from both sides, and that'll give me opposite of y is a negative 4, so you divide both sides by negative 1, and negative 4 divided by negative 1 is a positive 4. So your solution is negative 1, 4, and 2. Okay, so this is where these 3 planes intersect at this one point. This is your solution. Okay, now you can always double check to make sure that this is the correct solution by replacing x, y, and z into one of the other equations, not the last one you used. So we're not going to use equation 1 because we used it to solve for the last variable. So if you want to make sure that you didn't make mistakes and you have the right answer, just pick one of the other 2. So I'm just going to pick this bottom one down here since it's right here. And if you replace x with negative 1, 4 times negative 1 is negative 4. And then y was 4, so 2 times 4 is 8. So we'll say plus 8. And z we said was 2, so it's going to be minus 2. You can think of that as plus a negative 2. And if this all adds up to equal -2, then we know that we didn't make a mistake. So -4 plus 8 is a +4. +4 plus a -2 is a +2. So we know that that works. That's our check. Okay? So this is the correct answer.